here, they want us to find the concentration of my hydroxide. However, they've only given me the concentration of my hydronium. So in this case, one way you can try to solve this is look for one of the equations that has both of those terms in it. All right, so I'm looking for an equation that has both hydroxide concentration as well as hydronium concentration written in it. And in this case, it's just my Kw. Then you might say, well, I don't know what the value of Kw is, but guess what? It's given to you on here. So in this case, I can say that my Kw is going to be equal to my hydronium concentration to that of my hydroxide. And if I solve this, I will see that my hydroxide concentration has to be equal to Kw divided by my hydronium concentrations. And if I do this, I have 10 to the negative 14 divided by 2.2 times 10 to the negative 14. And what does this give me? What? The next one, then they just want us to take this a step further. Now they want to know what the pH is. Luckily for us, we have an equation that does that nicely for us, because this equation here says that pH is going to be equal to the negative log, and anytime the log function is written this way with nothing written, subscript, just assume that it's going to be in base 10, right, times the concentration of my hydronium here. So in this case, I'm just looking at pH equals to the negative log, then the concentration of my hydronium is 4.3 times 10 to the negative 14, and then what did this one give us? Anybody? Okay, 18.37. Anyone confirms? Okay, good. And here, I would say always write the pH calculations in up to 2 decimal places. Why? Because most pH meters, that is what you're going to get, right? But unless the question says that you should round it, then you can go ahead and round the number. If not, always report it that way. Here, we couldn't just say that my pH was going to be 14. Why? Because it is not 1 times 10 to the negative 14. But if you think about it, you say, okay, my answer has to be closer to 14. And look, we actually 13.37. That's closer to 14, right? And then you can just helps you verify your answer. This one here is a little bit complicated, but we have all the tools that we need to be able to do it. And in fact, we can do it in a number of ways. So one way we could do it is think about, well, they want us to find my hydroxide concentration. However, they've given me the pH of my system. So you can do it, there's one more direct way, the other one is a little bit indirect. So here, what do? I know that my pH is equal to the negative log of my hydronium concentration. And this, I told you that this has to be in base 10. So what I can do here is go ahead and divide both sides by negative 1. So this becomes positive and I have negative here. Then I can raise everything to the power of 10. If I do that, I can get rid of the log function. Now I see that I have 10 to the negative of my pH equals to my hydronium concentration. If that is the case, now I have 10 to the negative 7.4 equals to my hydronium concentration. And what did this give us for the hydronium? Anybody? Okay, for not the final answer, but for the hydronium concentration. Anybody?
I got 3.98 times 10 to the negative 8.
Okay, 10 to the negative 8 m. Right? And in this case, I cannot stop here because this is only my concentration of hydronium. The question wants hydroxide. But I know that Kw is equal to OH minus, and then something like that. So if I want OH minus, it has to be Kw divided by concentration of my hydronium. So to do that, I can say that, well, I have 10 to the negative 14 divided by 3.98 times 10 to the negative 8. And this now will give you 5 times 10 to the negative 7. Confirmations? Okay. Right? So we could have done it this way, right? You can, if you prefer, because now you have a lot of equations, you just choose like, it's like a la carte, right? You just choose whatever you want. In this case, I could have done it differently because I know that pH plus POH is equal to 14, right? So here, if I want the hydroxide concentration, I can do it a little bit more directly because guess what? I know that POH is equal to negative log concentration of OH minus. So here, I first of all need to convert this pH into POH. So how can I do that? I can go a step further and just say, okay, POH has to be equal to 14 minus my pH. My pH is over here. So if I have 14 minus 7.4, that gives me a POH value of 6.6. That's right. Then if this is 6.6, now I can do it a little bit more directly. I'm just going to use the same equation here, except that now, instead of hydronium, I have my hydroxide. So I can have my 10 to the negative POH equals my hydroxide concentration. So if I do that, this is going to give me 10 to the negative 6.6.